Well, why don't
and-
we do quick self-introductions, the three of
Okay.
us? I know the folks who have joined this session are able to see us, so that might make sense. We can go in order of how we'll be presenting. So Jean, why don't you do a quick self-introduction?
Okay, my name is Jean Carroon. I'm an architect in Boston, Massachusetts, a 60-person firm, Goody, Clancy. We work mostly in academic and government sectors, pretty much along the eastern seaboard. So I'm delighted to be with you today.
Thanks, Jean. All right, Dickson.
I'm Dickson Despommier. I'm an emeritus professor at Columbia University in the city of New York. I also am an adjunct professor at Fordham University in the city of New York. I am a microbiologist by training, but I have entered the back door of agriculture through vertical farming. And I hope I can follow up on what William McDonough said this morning, because it was a very inspiring presentation. And the beginning of his presentation started with the concept of the tree, and I'm going to follow up on that.
That's great. And hi, all. I'm John Lanier. I'm the executive director of the Ray C. Anderson Foundation. We're a philanthropic organization that supports environmental sustainability and works to advance the legacy of the late Ray Anderson, who was the founder and longtime CEO of Interface, the world's largest carpet tile manufacturing company. He was known as a champion for sustainability within the business world, and you'll notice, I don't believe that the description of this session changed from when we did our pre-meet with us speakers, but we're actually going to be exploring a bit more of the climate side at the intersection of the built environment. So you'll hear a little bit different. I'll be doing the last presentation. For anybody that has questions, we're each going to do our presentations and then have a chance to discuss and respond to questions. So if you have questions for us, feel free to put them here in the chat, and after we've all gone, we'll pick those up. So Jean, take it away.
So just reassure me that you and the audience can see my slide.
Yes, we can.
That's great. All right, then, because I can't see anything but my slide. So flag if something goes wrong. So actually, as Joan was saying, I want to talk about how building reuse ties to climate action. And I want to introduce a concept that ties with our keynote speakers, just about the urgency of the moment and the time value of carbon. So you'll see in our presentation that I'm talking about the next 10 years, and Dickson's talking about the next 100, and we're looking at different time frames in how we create a healthier world and a more circular economy. So within the building sector, we architects and many others are extremely aware of how the negative contributions of buildings, and we see a graph like this quite often that quantifies that building operations are contributing 28% of all carbon emissions. Oops, I must have this on a timer. But what we also want to focus on is that building materials have a major impact. The extraction and manufacturing of materials is contributing about 11% of global emissions, and that is gaining in importance as we see building operations contributions going down. I always like to remind people that it's not just about emissions, it's really about what we're doing to the planet. And the extraction of materials that we use in buildings has huge environmental impacts, and they particularly impact very vulnerable populations. So our global extraction of materials has doubled in the last 40 years, and it's set to double again. It's really important that we think about what we're doing and how many materials we really need. So my presentation will be a little bit graph heavy. Bear with me. You can ask questions afterwards. But if we look at driving emissions down, the next decade is really important. The sooner we drive emissions down, which is what the green chart is showing, the more likely we are to meet the Paris Agreement. I'm going to use a case study to demonstrate this. This is something we quantify in our work. This was a university residential hall that was a complete renovation. It's a building that is easily considered a tear down in the current world because of its age. The 70s buildings are very easy to dislike. Our renovation scope was a complete renovation, a gut, as we say, taking everything out, looking at the outside, reconfiguring, modernizing, making it accessible, changing the way the building performed for people and in the way it performs for the environment. It also involved looking at the outside of the building. It had some unusual challenges. Perhaps the best was that it only has 8 feet, 3.5 inches floor to floor. So it's pretty tight. It also had a pretty unforgiving structure, which means you can't drive systems anywhere you want. And then the client added a little complexity by keeping the building occupied during the renovation. We did pretty minimal changes to the envelope. We find actually that air infiltration is the biggest thing you can do, decreasing air infiltration to drive energy use down. And that usually means, and for preservationists, this is always touchy, but it means looking at the windows. And then it means looking at building systems and how they're distributed, which in this case, we were trying to leave them exposed. We were really making them a part of the architecture. And we are also dealing with the fact that we were in a flood zone. So we were moving some systems up to the roof. The new building is everything, the new old building is everything the client wanted. It's gorgeous. The students love it. We think it has another 50 years of life. But what we wanted to share with you today is the fact that we did a lot of analysis on this building. We calculated not only what the energy use reduction was, which we cut in half, but what the embodied carbon was. And that calculation is done using a software program called Tally, which we tie into our computer, our building model that we designed with. And this is the relative impact of the materials that are in the building. So the greatest carbon impact from new materials was really coming from all the interior materials, the interior walls and the fit out. And that's an important thing to acknowledge because people usually think it's going to come from the structure and from the windows. If we start to graph this, if we look at the fact that we've invested in carbon, which is why the brown line is a little above the green line, but we've reduced the operating, then we have a graph that shows the carbon impacts over time and what happens at 2030. So the payback is 2 years. If we say, well, what if we had replaced the building and we improved the energy performance so it has a flatter operational curve, the payback is 11 years. So that's really good, but it's still not as good as the renovated building. But you see that they're actually online to cross at some point in the future. But then we say, what if we green the grid? What if we stop using high carbon materials to make energy? So all the buildings flatten in their long-term performance. But now the replacement building and the renovated building never cross. The renovated building still has the lowest carbon impact over time. And this is just for any geeks in the audience that want to know what our assumptions were. But the assumption based on data is that the new building would be 10 times the carbon intensity of a renovated building. And that number is coming from the Carbon Leadership Forum out at the University of Washington. Our big takeaway as a firm, and we actually run this kind of analysis on every project in our office, including both renovations and new. Our goal is that in every project that we're saving more carbon than we spend by 2030. We think the next 10 years are absolutely crucial. We know that we are destroying the planet, and we know as architects that our strongest our most potent fire extinguisher is existing buildings. The more we can keep existing buildings online and make good investments in them, the less carbon we're going to create as builders, designers. We're excited to see that carbon reduction strategies are really becoming an international conversation, and that embodied carbon, which really stresses the reuse of existing buildings, and as a preservation architect, how could I not like this, is really a leading conversation now around the world. I was just looking at something yesterday in London, speaking in London, oddly, in Sarasota today. So we'd like you to spread the word. We'd like you to use this power of information in your actions, because we believe that building reuse is the most potent climate action we can have. Thank you. I'm out. Now I have to figure out how to get out of this. So, and come back to you.
Jean, that was great. Tim, do you want to introduce yourself as our moderator now that you're able to join us?
I'm Tim Rumage, the moderator who couldn't find all the buttons to push, and I'm a professor of environmental studies at Ringling College of Art and Design. But we should move on to Dickson.
Could you load my slides, please?
Well, okay, let me see if I can. Okay, let me do that. And
we're getting closer.
well, so let's just do it this way.
That's the one.
Now we
full screen.
Is that now showing up?
It is, but it's there. You go. So, can you advance? If I say next, would that be
yes?
Great.
Yes.
Okay. So in 10 minutes, I want to share with you my view of what I would like to live in 100 years from now. This is a new question that you should be asking everybody, and that is not what do you think the world will look like 100 years from now, but rather how would you like this world to look 100 years from now? And so what you're going to hear and see is my vision of this. And as Jean said, there's no one size fits all for how to do this. So this is my take on what's possible. And then the application of this is already in place. So we can see for the first slide, please. Tim, first slide, please. Thanks. Sure. So I'm of the opinion that grids are a detriment. And the more we can get off a grid, the better off everyone's life will be, as long as we can create independence. And the reason for that is the next slide, which Jean referred to, and so lots of other people did too, about the rapid climate change issue and how it affects virtually everything, including food systems, energy systems, water systems, etc. So what I'm going to present to you is a thumbnail sketch, and I'll share these slides with anybody that wants them, as to how I think this might evolve over a 100-year period, or perhaps even a little bit longer than that. Next slide, please. So we have to be able to do it, because if we don't, we'll become extinct. We'll end up in some museum jar of a species that came to this planet 100,000 years from now to find all of our skeletons among the wreckage of what we created. Next slide, please. So I think we can do it. And in fact, if I didn't think we could do it, I wouldn't be saying this. So here's my view of what the world will look like 100 years from now. In fact, since the urbanization process is already underway, not always good, we will have 80% of the people of this planet living in cities in another 50 to 100 years. So why shouldn't they live in a much better condition than they are now? And so what I will predict is that we have the possibility of making all city buildings sequester carbon by using engineered wood products like cross-laminated timber. We have the possibility of allowing all of their clear photovoltaics. We would call them windows, but we can also engineer them to produce electricity, supply energy for that building. We, of course, could insert vertical farm systems into that building itself so that the building could now produce food as well, and varieties of food, not just leafy greens. And finally, we could harvest rainwater and get off this drought flood regime that we now currently find ourselves in. Next slide, please. So these are thumbnail sketches of how each one of these might evolve. First of all, carbon sequestration. First slide, please. Next slide, please, I should say. So there's a group at Yale University as part of the forestry school that's learning how to re-engineer wood, which you would call trees, into pliable building materials, which could then be used to insinuate into cities that are growing. That are, if you want to replace a building, why not replace it with something that sequesters carbon rather than gives it off? And here's the metrics for that, and you can go to their website. It's a wonderful website, but it's not just Yale. Let's see the next slide. We're already doing this, and here's a building that's already up. It's called the T3 building. It's in Minneapolis. It was designed by Michael Green from Seattle, and it sequesters 3,646 tons of carbon. Remember, those were trees at one point, so they had to allow for the reforestation of where they took those trees, not in this case, but in most cases, yes. And then when those trees grow back in another 20 years, that's double the amount of carbon that you see now. And so if we continue to do this over a longer period of time, you can imagine a lot of the buildings in the built environment made from this material. Next slide, please. It's not just the exteriors of these buildings that are attractive, although here's one that is. Next slide, please. Shows you what it's like to live basically inside of a tree. And William McDonough in his presentation said he started at Dartmouth wanting to go into international affairs, but rapidly changed over to a naturalistic view of life. And what could be more naturalistic than walking inside of a tree? And so this is what it might look like. This is, of course, a re-engineered tree. Next slide, please. Here's another look at what it might be like to actually work inside of a tree. And you can see mostly wood products, cross-laminated timber, and other varieties of that technology applied to the built environment. It's a wonderful, warm, inviting atmosphere that you can imagine here. Next slide, please. We can generate energy, next slide, please, by actually repurposing windows. Here's a group at MIT, but there are others at Michigan State, UC Cal, Berkeley, and places around the world that are looking to develop materials to coat windows with, which will turn them into photovoltaic cells. And they're succeeding. And the amount of conversion is low today, but I'm predicting 100 years from now that we'll have photovoltaics that are clear, that are more efficient now than the current photovoltaics that we think are highly efficient that we're putting on our roofs. So therefore, it's possible that a building with windows could actually supply enough power and maybe even make excess power for the built environment that's about to emerge. The next slide, please. Any window can be converted this way. Next slide, please. So imagine a built environment that you see today in New York City, for instance, with glass and steel buildings. Just convert that glass to photovoltaics and you've got a whole new way of looking at cities. Next slide, please. Not that that would be easy, mind you, but it might be necessary. And of course, we can produce food indoors because we've been doing it for hundreds of years in the form of greenhouses. And now with finally the stacking of greenhouses on top of each other, we now have vertical farms. Next slide, please. Sorry for this delay, but that's my fault. Sorry, Tim, I didn't get in touch with you last night. I should have. The greenhouses have been in vogue since the 1700s. They still are. But now they've been converted to stacked greenhouses. No, go back, please. The stacked greenhouse is now what we're calling a vertical farm. And this is a Calera company, a vertical farm company located in Orlando, Florida. So if those of you living in Sarasota that want to go visit a vertical farm, simply drive up to Orlando and you can find this wonderful addition of a brand new building that's generating lots of food. Next slide, please. So imagine every building in the built environment with that kind of capability and all of these advantages of growing food indoors, using less water, doesn't require soil, can be carried out anywhere in the world, prevents foodborne illnesses, and lastly but not leastly is the fact that it allows for rewilding of abandoned farmland. And that's the return of nature. And that's, I think, a critical issue here is that can we substitute vertical farms for farms on the outside so that we don't have to worry about where our oxygen is going to come from or where the air purification and of course, the lumber for the cross-laminated timber. Next slide, please. We can use these varieties of technologies, hydroponics, aquaponics. People criticize them because they're not natural. My take on farming is that it's not natural. Farming is not natural, depending on where you choose to start talking about farming, including 12,000 years ago in the Middle East. So it's a new iteration of human activity, and it's in 12,000 years it has captured as much land needed to grow food as the size of South America. We have to change that or we're doomed. This is a small print list of vertical farms. 3 years ago, these did not exist. So it's a relatively new technology and archetype that we're talking about to replace farms outdoors with farms indoors. And you can live in the city and have a good diet at the same time. Next slide, please. They're all over the states, and here's some more listings. The next slide, please. Here's one that's only 2 miles away from where I live, basically down in Newark. It's called Aerofarms. Next slide shows you what it looks like inside of this redesigned ironworks in Newark, and it's a food factory, basically. It absolutely covers most of the space indoors with growth of plants that are all edible. And they're healthy, the water is pure, the nutrients that they feed to these plants has been chemically certified not to have pesticides, herbicides, heavy metals, things like that. Next slide, please. Here's the one in Calera, a little bit up closer in Orlando that you can see more detail. Next slide, please. This is a company called Plenty. They just recently formed in San Francisco. They want to cover the entire West Coast with growth buildings that manufacture enough food to feed enough people to make a big difference in the way health is perceived, and especially in inner cities. Next slide, please. Here's the perfect combination of a vertical farm and a restaurant. It exists. It's in Utrecht, the Netherlands. The vertical farm is on the top, the restaurant is on the bottom, and whenever we can feel safe enough to go back to eat, I would choose to go there for my first meal. And I know that Holland is experiencing a little bit of a blip on the COVID-19 as well, so this is not the time, but this is the model that I think could succeed wonderfully in the cities. Next slide, please. You can even feed cattle with food that you grow indoors, and in fact, it's much better for them than what you give them outdoors, and it takes up far less room than it would take to grow this much grass outside, and the harvesting is so simple, this could easily replace lots of things like feedlots, etc. Next slide, please. In case you do want to eat some meat, that's the point. Finally, harvesting rainwater. I mean, it's raining outside right now where I am, and if New York City could collect this water over a year's period, they would collect 245 billion gallons of drinkable water if all their buildings could, of course, harvest that water. Next slide, please. We're designing buildings to harvest water now. Here's a futuristic design of a building. It's got all of the bells and whistles that you'd want in a building, except for one that I'm worried about, and it's made out of the wrong materials. But nonetheless, we're thinking along these lines. And in fact, next slide, please. There are 2 buildings in Shanghai that already do this, and there should be many, many, many more, because it's not just a question of whether you have enough fresh drinking water, it's whether you just, period, have enough water. And I think There's tons of water. It's just that we mismanage it so badly. Next slide, please. This is the ultimate resolution of what I've been talking about in terms of concept buildings. This building is made out of cross-laminated timber. Each one of those triangles is an apartment house inside of which you can grow food, not all the same crops. Imagine now everybody growing something different, or maybe by floor. You're living in the building, you've got enough to eat for yourself. At the bottom is the grocer of all the leftovers that you can sell to anybody that wants it. And it's a water harvesting building. The glass doesn't yet harvest energy, but I'm sure it will in the future. Next slide, please. So I will end by saying, let's create a livable future for everyone without harming nature in the process. We've harmed nature so much that it's no longer our friend, it's now our enemy. We're living through that right now. The COVID-19 is not an accident of nature. It was an accident. It was an event waiting to happen, simply by encroachment and getting larger in terms of our population. This is what you get if you don't pay attention. Next slide, please. If we succeed, and it's not an if, because if we don't succeed, then it doesn't matter because we won't be here. If we succeed, then nature will repair itself. If you don't believe that, I can show you lots of places around the world where when we abandoned the property, it returned to the ecological setting that it was before we damaged it. This is not only true for large swaths of land in places like northern China, etc. It's places like Korea, North and South Korea, the demilitarized zone, etc. It works whenever we agree to leave it alone. Next slide, please. If you want to learn more, I've got a new book. Well, it's actually not new, it's an old book with a new chapter explaining what happened from 2010 to the present with regards to vertical farming, and it's been an explosion of activity. I can't believe it happened because we obviously didn't start this concept in my classroom with that in mind, but nonetheless, it's happened, and so I pander to your to your sensibilities. It's not an expensive book. I'm not going to make a lot of money on this, but I want to spread some ideas that are worth talking about. So the last slide says what I've said for many, many years to everybody who's had a difference in my life. Thank you for listening.
Thank you, Dickson. All right. I will bring up the rear. And no slides for me, so you get the old-fashioned talk here. I'm going to introduce you all to a new initiative that our foundation, the Ray C. Anderson Foundation, has been involved in launching. And I'm also thrilled to say that South Face is one of the partners in bringing this to bear as well. It's an initiative called Drawdown, Georgia. I want to tell you a little bit about the backstory of it, what has happened recently, and at the end I'll tie it to the built environment in particular so that it meshes with the talks that you've already heard. But I'm also going to drop the website now into the chat for anybody that wants to follow along with what this is. So many of you may be familiar with Project Drawdown. They're an organization, in case if you aren't familiar, that researched and modeled the world's most substantive solutions to reverse global warming. And their work was tremendous. It showed that there was so much more than the conventional wisdom had shown that we can be doing right now to reverse global warming. So to me, that was an optimistic message that the data shows we have the tools at hand as a species to reverse global warming. But the one thing that Project Drawdown did not and could not do was to tell any particular region what they should be doing. So for instance, our foundation is in Georgia, we're in Atlanta, and that's where our network is, that's where our home is. Ray Anderson was fond of saying, brighten the corner where you are. Our corner is Georgia. And if I look to Project Drawdown's initial ranked list of the most substantive solutions, let's say I looked at number 5 on that list, tropical forest preservation. We don't have those. That doesn't work for us. So we felt like it was an important contribution that our foundation could make to provide the resources to go and answer a very simple, but it turns out complicated question. What climate solutions work best in Georgia? What would the data show if we could model climate solutions scaling here in our state and eventually perhaps achieve drawdown? What if the state of Georgia could be the first state in the United States to achieve carbon neutrality and then go beyond to become a carbon sequestering state? That's what this was all about, but it started with that research piece. And so we were proud 18 months ago to fund a coalition of universities, the best minds in the state of Georgia, from Georgia Tech, the University of Georgia, Emory University, and Georgia State. Professors from these 4 universities collaborated to explore the solutionscape for climate in Georgia. They down-selected from Project Drawdown's initial list and came up with a list of 20 high-impact climate solutions that work in Georgia. They're spread across 5 different solution sectors: electricity, transportation, buildings and materials, food and ag, and natural sinks. And what is most compelling about all of this is it shows how much opportunity there is for the state of Georgia to act and lead on climate right now, not in the future, not with technologies that will come and save the day, but things that we have right now. And their research also shows that if done right, it can be profitable. As many people in the space know, if you work on scaling climate solutions, the payback periods will come, maybe faster than you might even expect. The team that researched this kept a 2020s decade lens on this. And so all of their research was about what can we do in this critical next decade. And I encourage everyone to spend some time on the site and explore the different solution sectors. But what I want to share with you here is connecting it to the built environment. I want to give you a sense of what's possible with certain solutions as they scale. And what I'm about to share with you is a framework we've created for all 20 solutions across all 5 of the different sectors. But I'll specifically speak to buildings and materials and the impact that the 3 solutions within that sector have. So the research team first had to identify what is Georgia's carbon footprint. If we want to achieve carbon neutrality, well, how big of a mountain do we have to climb? And their research showed that Georgia has about 125 million metric tons of net carbon footprint each year. So 125 megatons. That's the problem. In deciding what their high impact solutions were, they wanted to know which solutions over the next decade could get at least 1 megaton out of that 125 in annual footprint. That was the threshold for a high impact solution. And 3 of the buildings and materials solutions that they looked at got over that threshold. And they reduced each of these solutions to a metric of what 1 megaton looks like. That's hard for us to relate to often. We certainly can't relate to the gigaton size problem that humanity needs to solve. But when you come down to the level of 1 million metric tons, 1 megaton, well, we can make that relatable. So one of the solutions, retrofitting, what does that look like? What does it take for Georgia to get a 1 megaton reduction if we focus on retrofitting? Well, if we retrofit 20% of Georgia's homes beyond the baseline of what has been done now to increase energy efficiency, 20% of Georgia's homes would yield a 1 megaton reduction. And we can do a lot more than that, but that gives you that one bite-sized bit of carbon reduction. What about the next solution? Recycling. Again, this is the buildings and materials sector. Turns out that Georgia is not a very good state for recycling right now, but that means that if we get better, there's a lot of opportunity. And so if we could recycle at least 20% of currently disposed paper waste, that would also yield a 1 megaton reduction in our carbon footprint. And then the last solution within this sector, refrigerant management. This is something that Project Drawdown called out as a significant opportunity. If we can stop the chemicals in our air conditioners and refrigerators from leaking and going up in the atmosphere, they are super greenhouse gases, these HFCs and other halocarbons. So if we could retrofit refrigeration systems in Georgia's grocery stores, just our grocery stores, to an average leakage rate of no more than 8%, that would yield a 1 megaton reduction in our carbon footprint. And if we can get enough of these bite-sized pieces, 125 of them, in fact, Georgia will be able to achieve drawdown. To me, what's most exciting about this effort is that it makes it something anybody in our state can engage in. You don't just have to be able to put solar panels on your roof. The rooftop solar is one of our 20 high impact solutions. There's a place for everyone in this effort, and that's what we're really trying to do, to build a movement of Georgians focused on climate solutions. And we invite other states to join in and maybe just maybe beat Georgia to achieving drawdown. Thanks, y'all.
Very good. Thank you all very much. First, you had any questions for each other now that you've heard your presentations?
Well, I don't know how I can work with Gene. I would love to come into your studio and learn, because I need to know a lot more about what you're doing. And, you know, I'm still young enough to be able to learn something without forgetting it. So it's inspiring to see how many levels of change are necessary in order to affect a larger change. That's basically what I'm saying.
Yes, and I would encourage you to go look at the Carbon Leadership Forum website if you haven't. But I wanted to ask John if other states are doing this. Project Drawdown is an overwhelming book in many ways. So to see it distilled on a regional level is really exciting. And Project Drawdown sort of skirted around the existing building issue. So it sounds like your group has really focused in on that.
Yeah, so we're the first state to do this being a high quality academic look at the carbon reduction potential of our solutions. Many states are ahead of Georgia in actually doing climate action, at maybe having climate action plans, but to take this solution oriented approach, we're the first ones to do this. There's an important point here, and it's that the 20 identified solutions are not meant to be the entirety of what we can do. And what your work is focused on, preserving embodied carbon, it just turns out to be a solution that was difficult to model and to measure. And so it didn't make it into our list. It's still critically important. And that's true of so many other solutions that either have a longer time frame than the 10 years that the research group looked at, or just are difficult from a policy standpoint to call solutions. For instance, if we saw a price on carbon, that is not in and of itself a climate solution that can be modeled, like, for instance, retrofitting buildings, but it still would be a critical enabling factor. So there's so much more that goes into this work than just saying there's 20 things we should be doing and let's do them.
And in your agricultural sector, did you see anything like Dickson is talking about, or is there any initiative for that?
So the vertical farming piece doesn't rise to the level of the carbon reduction. It's still a valuable and important thing to be doing for a wide range of things, and probably would on net be able to contribute to a carbon reduction. But it doesn't get over that 1 megaton reduction threshold if scaled over the next 10 years. The things in the ag sector that do have the payback are reduced food waste, shifting to a plant-rich diet, which does dovetail somewhat with what Dickson was talking about, and scaling conservation agriculture, which involves a whole host of practices, including no-till agriculture. I saw somebody in the chat to call that out, and cover cropping, things like that. So again, people, please go to our website and spend some time exploring all 5 solution sectors.
One question for you, Dickson, from the group is, could you tell everybody the name of the vertical farm in Orlando one more time?
Kalera. It's Kalera. And they're not just in Orlando, they're in other places too. But I must say that one of the largest actually located to Las Vegas. It was a Chinese funded company. And the reason they picked for Las Vegas was not because of the population or because they have a lot of high-end chefs. They picked it because Las Vegas has one of the lowest costs per kilowatt hour, because they're capturing all of their energy either from hydroelectric power, wind, or they have a solar farm. So they're completely off the carbon grid. So naturally, it's going to take less energy to run a vertical farm. So that's where they moved. So that you're going to get that happening, because I think that if you could live off the grid on all 4 levels, food, water, energy, and carbon sequestration, you don't have to live in a city. You can live anywhere you want.
Another thing that was brought up in the chat and for several people was the fact that with these changes, there are ways not only to return places to nature, but also just to more easily include nature in the design and bring nature and biophilic experiences into the urban environment at this point.
This is right. I mean, you're seeing buildings now designed with facades that have trees growing on them. And, you know, there's one in Milan, there's a couple of more in other places. If you can imagine a city like this viewed from a larger distance away than just the city limits, you'd swear you were looking at a forest rather than a city. And so that's a way that you could probably repurpose the outsides of buildings that currently exist to include within them these living walls that do everything they do for a forest right in the city itself.
And all of you have stressed the importance of these changes happening, not only happening, but really happening timely fashion in this current decade. So what do you see as missing pieces of the catalyst to make that happen in your particular areas or fields? Is it, you know, is it making people more aware of the options? Is it changing regulations in communities? Is it what do you see as sort of the hang up in moving these things forward at the pace at which we need?
Well, from my standpoint, I hope that Drawdown Georgia, this creation of this movement rooted in data, is that catalyst. Because what we're trying to do is to depoliticize climate solutions by showing that sectors as diverse as our tree farmers, all the way to our mid-level managers at Fortune 100 companies in Atlanta, all of them can be champions in the climate space, and it's good for a whole host of reasons. Importantly, for equitable reasons. You can advance environmental justice through the scaling of climate solutions. We want to create this room that people can enter through 100 different doors, and it doesn't matter which one you choose to open. There's a place for you within the climate solution space.
Either Dickson or Gene, do you have a comment you want to make along those lines?
The only comment I would make is that every state has 2 schools that were established in the late 1800s to ensure that agriculture succeeds. The IT schools, that's Georgia Tech, and then the agriculture schools, that's University of Alabama, University of Georgia. They all have ag schools. Every single state has an ag school. Every single state has an IT school. I would love to see them combine together an equal emphasis on living in cities and producing food within that environment. So an urban agricultural department within the agricultural schools would go a long way to convincing students that there are careers waiting for them when they graduate.
I would say for the
Go ahead.
to see happen in the world, I would love to see all the landfills closed, just closed. And I think it would change our economy because it would change it would push us away from our consumption and waste, as our keynote speakers talked about. And I would love to see a carbon tax, which is a tax on the externalities of what our material consumption the world. So not just a carbon tax on energy, but a carbon tax, a real tax on materials. And if I could get those 2 things, I probably wouldn't have to fight so hard to reuse buildings. But that's, a girl can dream, you know. That's,
and
you're not alone. You're not alone.
in sort of the moments we've got left here, Gene, is building reuse becoming part of the mainstream curriculum in architecture at this point?
no.
Okay.
No, I'm sorry to say it isn't. It is becoming part of the mainstream. Our American Institute of Architects is pushing hard, but we still don't see it, and putting out some great materials and some great advocacy. But I think the schools are lagging behind, unfortunately, and that's a shame.
And a parallel question to you, Dickson, are you seeing ag schools talking increasingly about vertical agriculture or indoor agriculture, or are you still teaching are you still teaching the only course?
No, not at all. The idea, I mean, was I know when it started because it started in 1999 in my classroom. As far as the term vertical farm, I know other people were thinking about it long before that and long after this too, I'm sure. But as soon as the book came out, I wished that I could have put pictures of the farms in there, but there weren't any. And that was in 2010. In 2013, when the paperback came out, I could put 3 pictures of vertical farms. So then in 3 years, 1 farm per year. From 2013 to the present, there are so many vertical farms now that I would have to make a 5-volume book set to show you all the details of all those vertical farms. So it's been a logarithmic expansion of the concept in so fast that it's outstripped the labor force of technical people that actually know how to work inside them. So I think education is the key for the future, for everything, of course. And for agriculture, it's how can we become stewards of the land? And every farmer wants to be a steward of the land, but then they have to, of course, make sure that their crops survive, so that there's fertilizers and pesticides and herbicides and all kinds of additives. And I know that a lot of farmers don't use that, but many more do. And it's just, we have to wean ourselves off of that and get used to the fact that nature rules. So I think it was Howard Odom at the University of Florida who said, nature has all the answers. What's your question?
Right.
And so our question is, how can we sustain life on Earth, including humans?
Right.
How can we do that?
Okay. And John, are you seeing other states or other organizations in other states coming to you to talk about how you created Drawdown Georgia to mimic it in other places?
Not yet, because we just launched ourselves. Last week is when our site went live and the research findings were fully unveiled. But we invite that, and we've put in the work to make the research methodologies as well as the overarching movement building efforts that we're engaging in something that we can pass on to others and say, here's how we did it. It doesn't mean it's the best way to do it, but we would love for others to do it. If Georgia's the only state that pursues Drawdown and others don't, then I'm not sure our work will end up mattering all that much. We need it to be a community.
Yeah. And there's a question for you, Gene, that I've seen here. When you all do the remodels, are you including the infrastructure for like electric vehicles and those types of things?
Yeah, actually, certainly we're seeing within our sector, academic and government, all buildings now are going all electric in the hope that someday where the power comes from will be not fossil fuel based. And
Right.
And as part of that, the electric infrastructure includes electric vehicle preparing for that.
Very good.
So
Very
we're
good.
just a tiny drop in the bucket. We need things like John is talking about in Dickson that bring people from all different directions. I love the metaphor that we have to create 1,000 doors for people to come through.
That's great.
Yeah. Very good. Well, I think we're according to my clock, we're way past time, so I should probably bring this to an end at this point. Now, Gene, both you and Dickson have said that we can share your slides if people request them.
Absolutely.
So they get in touch with the workshop. We will share those slides. We've also got your email addresses in there, so if there are follow-up questions for you three, people may be able to contact you individually. Right.
Good.
Okay.
Yep. Perfect.
Okay. Great.
All right.
Well, thank you all very much. This was very informative, and I can't wait to see our success at the end of this decade and all the steps and the growing steps in between. Thank you so very much.
Thanks,
Thank you.
everybody.
My pleasure.
Good.
Thank you.